Hi there, and welcome to another episode of Anything Arduino. With the Leonardo, the Arduino concept was pushed even further because the Leonardo could be used as a human interface device, HID, and it could be used as a keyboard and a mouse and could control those things, amongst other things. And that's good. Most of us already have a keyboard though, and most of us already have a mouse. What I wanted to have, and still do, and why we're doing this today, is I wanted to have a multimedia controller. There are on some keyboards that you have play and pause and all those, but I wanted to have my own device. So because almost always when you're playing music on your computer, it's in the background, and you really have to switch all your programs around to get to the media player to stop the music or change the music. With the multimedia controllers, you can access those controls immediately. And with the Leonardo today, and along with actually it's not a library, it's just some modification of the core code, we are going to make the Leonardo into a multimedia and remote controller. So let's do that. So this is not so much a library or anything like that. This is more of a hack or a modification of the code already built into the Arduino IDE. So first we visit the page stefanjones.ca. On his blog we find this page, Arduino Leonardo Remote Control Multimedia Keys Support for Arduino 1.0.5. And here he talks a bit about the Leonardo, and he shows a picture of the Leonardo, and he also has source files for everything located on this page on his GitHub. But I'm instead going to go through the steps that he mentions here. So first let's find the Arduino code. We do that in the local C drive, and then we're going to program files. If you have a 64-bit OS, then you need to go into the program files x85 folder. Here we have the Arduino, and then we have the hardware, and we have the Arduino cores, Arduino, lots of Arduino. Right, so here is the code that we are going to add to get the multimedia support. So let's see what they more say. Look up the files, USB API and HID. So let's do that. USB API.h. Copy that. Wow, that did take a long time to copy 5K. And also the HID.cpp. Let's copy that. So, done. Optionally grab the source files. We don't want to do that. So, let's modify the USB API.h. So we want to add headers for the new remote class. After the headers for the keyboard and mouse classes are defined, add the following definition for remote. And he says it's line 137. That doesn't have to be exactly true. It depends on changes done to the code. So in the USB API, Let's open that with Notepad++. So we have USB, and here we have the mouse, and here we have the keyboard. Let's see, keyboard, and there's the end of keyboard. So let's add that here then. Remote. And let's go back and see what it says. Save the file and you're finished with the headers. So save this. Save the file. We've done that. Adding class to hid.cpp. So you'll want to declare a new singleton for the remote class, located at the top of the source file. So let's do that. Actually, let's open up here's the singletons. So let's just add the last line here, remote, to here, line 32. And then skipping ahead to the very end of the file, we need to provide implementation details for the remote object after the mouse and keyboard are defined. This can be added before the two trailing and if statements in the file. So let's take this code. Let's take this code there, and at the end of the file they say there are two end ifs. True. So let's do that. Let's read that again, just so we made it. Skipping ahead to the very end, we need to provide implementation. Yeah, this can be added before the two trailing end if statements. Great. We will add one more change to the code, adding a USB HID descriptor for the consumer control panel page, which hosts the typical remote control and multimedia keys available to modern operating systems. Blah blah blah. The USB descriptor will be added after this section in the Arduino source. So if raw head enabled, let's find that. If def head, define raw head. Note that in the file, each of the usage line corresponds to a bit of data defined in the USB API.h. The final box leaves 6 bits remaining for passing around additional functionality. So here we have all the cross-platform support for controls found on IR remotes. So we have volume up, volume down, next, stop, pause, play, all these things here. Let's see, if raw head enabled, let's find that. If raw head, 2 words, raw head enabled. There's one. If raw head enabled. So here it is. Note that the USB will be added after this section in the Arduino source. So after this section. And we have that one is not here. And collection. So let's place it here and hope that is correct. We will see soon enough. That's everything you need to do with the Arduino source. Save your work and try compiling a sketch with a profile for the Arduino Leonardo board. So let's get a sample sketch here. Sample sketch for Arduino Multimedia keys. Here's a play mute sketch that will just play and mute the sound. So we paste the sketch in here and we make sure we have our Arduino Leonardo chosen, and let's download. So this sketch, it will just mute and clear the muting on the Leonardo. So it will send the mute command and then it will clear it. So now it finds this new HID device. Let's start some music playing here. And there it was muted and unmuted. So it goes with 5 seconds of delay. It mutes and then it waits 5 seconds and it clears the mute. And this is on a global scale. It's, as you can see here, it is not inside the VLC. It is outside in the, you can't see that. It's down in the right side of the start menu. You see that it is muted. So let's do something more interesting. Let's make another sketch. Let's connect a button and let's make that button play pause functionality. So let's begin by opening up the example file for button, digital button. We'll just use the example file, it's good enough for us. So we have the button on pin 2 and then this example file just blinks a LED. We don't want to do that, so we remove that and we remove that. Actually, we don't need the else statement at all for the moment. So let's start by hooking up the connections for the button. Okay, so I'm just gonna quickly show how to connect a button. The most common way to do it. You have a button and one leg is connected to 5 volts. Yeah. The other leg is connected to pin 2 in this case, because the sketch says pin 2. It is also connected to ground, but not directly to ground. It is connected to ground with a 10K resistor in between. So when the button is not pressed, the pin 2 is connected to ground through the resistor. When the button is pressed, 5 volts is going to pin 2 and the Arduino senses that the button is pressed. I release, it goes back to ground through the resistor. So, very simple, but just for those who haven't done this before, this is how you do it. Okay, so we've done that. Now we're going to make the necessary changes to this sketch. So, if button state is high, that's when we press the button. Then we need to get some extra ints here. Int play state equals 0. So 0 is paused, 1 is playing. So that is the default. We will assume that when we plug the Leonardo in, it's not playing. So if button state is high, then if play state equals to 0, then we're going to press play via the HID interface. So as if it had been a multimedia keyboard, we're going to press play on the computer, and we're going to change the play state equals to 1. Else, if it's not, if play state is 1, sorry, then remote pause and play state equals to 0, and then that one. Also, we need to, this will loop, and if we're not fast enough, it will come back and just play pause in an infinite loop. So we'll do this while button state equals high. We're just gonna do nothing here, and for just to be really safe, just get a small delay in here as well. One thing in the while loop here, of course, I can't, this will be an infinite loop as well. I have to do a digital read button equals, yeah, I have to do like that because I checked the button state up here. It will be high. If it's high once, it will just stay in this loop and we won't get out. So sorry about that mistake. Button pin. So now let's try again. We play, press it and it plays, press it and it stops. One thing to think about here is that this global functionality that I wanted isn't working on VLC by standard, at least not if you have a Swedish Windows 7 and an English VLC. I don't know why. You have to make some modifications in the global hotkeys in VLC. So it's not a problem with the Arduino code or functionality as such, but it is in VLC on Windows 7. I will show you it working on a lot of different devices. Okay, so here we have a VLC player on a Macintosh or Apple computer, and here, let's see, you can see actually you have to press it twice on the Apple computer. I don't know why. So it's second works, and then you press, doesn't work, and so on Apple you need 2. And it doesn't matter where I am. I can be in here opening a new page and mute, and it's just the same as this one, same On Mac, it connected to a Raspberry Pi running XBMC. Raspberry Pi is over here. So I usually have a keyboard, but I could instead have this instead of a keyboard with a few other buttons, left, right, enter, and up and down I would actually need. So same here, double press to pause the music, and then it goes again. Here we see it working on in another computer, Windows 7 64-bit version. We are running Windows Media Player in the background, and so Windows Media Player is not the chosen app. So with Windows Media Player, it works in the background as well. So we just have to get it to work on VLC as well. So this is it for today. Now we have some extra functionality of our Leonardo, and we can use it as well as a multimedia keyboard. So hope to see you next time. Take care. Bye. Oh, subscribe. Don't forget that.